let's go over what you're going to find in your calculus book most likely on absolute max and mins. Let's read through this together and make sure we understand what it's saying. So it says for any function, f of x, so just some function, if it's defined on some set D, and D can be the domain of the entire function, or the domain could be, or D could be some set that the book tells you or your teacher tells you that you're looking at. We'll look at that a little bit later on, but D is just some set of numbers for which f of x is defined. Then any little d that's an element, that's what this sign means, of big D. So little d is an x value. Any little d that is on the set of numbers that f is defined, if f of d, that's the y value, okay, so if you plug d into f, you get a y value back out. So if f of d is an absolute max, or sometimes they call it a global max, depending on your book or teacher, f of d is an absolute maximum if f of d is greater than or equal to f of x for all other x's. All that says is, if you take any graph at all right, so we'll look at this graph on this domain right here. Let's say it goes forever down that way. Cool. The maximum point is right here, and since it is, so this value right here, if we call this d, well then this is f of d, and you can see that f of d is larger than all other f of x. For any other x value you choose, f of d is bigger, greater than f of x, for any x value you choose. So, that's all it says. F of d is then called the absolute maximum. D is where the absolute maximum occurs. So there's two kinds of questions that you might ask. They might say, find the absolute maximum. Well, the answer to that question is, it's f of d, it's the y value. Okay, so this is the y value that it occurs, and it's just f of d. Or they could ask you, instead of find the absolute max, they can say find where the absolute max occurs. Well, if they say find where the absolute max occurs, now they're not asking for the absolute max, they're asking for where it happened. Well, that's just d, that's an x value. So that's an x value, and that's just x equals d. And again, d is just where the highest point is. We'll look at a couple different graphs, and we'll find x. We'll find d, but it could really be any number. It just has to be the highest, the value that gives us the highest y value, the greatest y value. So that's an absolute max, and an absolute min, very similar. F of d, again, d is just any number, so the y value is called an absolute minimum of f of x on that domain, on d, if f of d is less than or equal to all other y values, all f of x for any x in that interval. So, if we limit our function to go from here to here, okay, so this is my x-axis. Let's say we're going from A to B, so we're going from A to B. Well, then the absolute maximum is the highest point. Well, it looks like, it's really hard to see here because I do this really sloppy, but it looks like this point right here is the highest value. It's the greatest value. So the absolute max, where this cursor, the absolute max is f of a, whatever that y value is there. Okay, now if I told you this value was 10, then the absolute max would be f of a, would be 10. Okay, so you write that. And it occurs, at x equals a. And again, a can be any number, so let's change it, say a is 4, alright? Well, it is at x equals 4. Cool. And a concise way of saying that is, the absolute max is f of 4 equals 10. That tells you where the max is and what the max is. Okay? The absolute minimum on this graph is just the least y value, the point that's lowest on the graph, so the absolute min is f of b. And it, just so you're not confused at these variables, this can be any number, let's say 10. Okay, I'm just making this up as I go along here. Let's not use 10 as 10. Let's say it's 10. And let's say the absolute is f of 8, and it's 2. Simple enough. If you have a graph, absolute max and absolute min, pretty easy to pick out. So, that is what all this nonsense says from the calculus book. And then it probably says underneath of that, or somewhere along the line, somewhere on this page, absolute maximums or absolute minimums are referred to as the absolute extremum, which is singular. And if you want to talk about plural, it's called absolute extreme. That's the plural version of that. Because sometimes If they say absolute extrema, they're talking about find the absolute max and the absolute min. And sometimes it doesn't have to be just one. So let's say we have this graph here that goes m for max, okay? It goes, we're making an interval from 2 to 15. So this value here is 3, and this value up here is 6. Okay? Well, and they say find the absolute minimum. Well, the absolute minimum is 3, and it occurs at 2 places, at 2 and at 15. So there are 2 absolute minimums, which is totally fine. So the absolute min is 3. So that's the lowest y value, and it occurs at x equals 2 and x equals 15. There you go. And the max, the same thing. The absolute max would be 6, and that would occur at, I don't know, 4 and 8. Okay? So, you gotta be careful about open and closed intervals, because if you want to find the maximum, the absolute maximum on an open interval, well, that's a little tricky. So let's say we're going, I'm just making up functions here. Let's say we're going from 3 to 12, and we have this graph here. Okay? So this value here is 2, and this value way up here is 7. Okay? Well, if I ask you to find the absolute maximum, well, the highest point is at 12, and the absolute max is 7. All right? That's easy. But there's a problem with this down here. This open circle here means that there's no point. That means my graph goes all the way up to this point, but there's no point there. So the absolute minimum looks like it should be 2. But the problem is it never gets to 2. There's an open circle there. So this is called an open interval over here. It's open on the left side at 3. It's closed on the right side at 12 because the point's in there. Okay, but it's called open because there is no lowest number. A lot of times kids will say, well, if it should be 2 and you can't get to 2, well, they'll say, oh, great, well, the lowest number then is 3. Well, there's a bunch of numbers in between 2 and 3 here. And the problem is, no matter what number you choose, let's say you find the function value at 3.1, and you get this point right here. Well, no matter what point you choose close to 3, I can always choose another point closer to 3. If you choose 3.01, I'll choose 3.0001, and my y value will be closer to 2, but it won't be 2, but it'll be smaller. If I choose 3.001, you want to do me one better, you can say I'll choose 3.0000001. Okay, great. So you can get as close as you want to 3, and that means you can get as close as you want to 2 here, but you cannot get to 2 because it's an open circle. So there is no absolute minimum here. All right. Let's play a little game, and it's called determine if f of x has an absolute max or an absolute min on a given interval. All right. So we'll do number 1. F of x is x cubed on the real. All right. For now, we're going to answer these questions by looking at the graphs. Eventually, we'll be able to do some calculus and do this. But x cubed looks like this bad thing here. It flattens there, then it goes up like that, goes up forever, and it goes down forever. Well, since it goes up forever, there is no absolute maximum. There is no number, there is no y value that's greater than all of the y values on the reals, because it just keeps going and going and going. Same thing on the left side here. It goes down forever, so there is no absolute minimum. It just goes down forever. Okay, so this, no. It has no absolute max and no absolute minimum. No absolute max or minimum. If we look at x cubed, same function, different interval. Now I'm limiting my interval from 1 to 3. 1 is open, 3 is closed. Well, x cubed from 1 to 3 looks like this. At 1 it equals 1, and at 3 it equals 27, which we're going to pretend is right here. Okay, so it's 27 right up there. But this down here is going to be an open circle. So, there is no absolute minimum because it's an open circle down here. There is no point that you can say is lower than all the other points, because it should be 1, but there's no point at 1. There is an absolute maximum. It's 327. Alright, some crazy girls knocked on my window. Okay. So I'm not going to write that out, because I'm getting lazy. X squared on the reals. Okay. X squared looks like a parabola. Well, it doesn't look like a parabola. It is a parabola. X squared, well, there is no absolute maximum because this thing goes up forever on both sides, so there is no point that's higher than all the other points. But there is an absolute minimum right there. 0 is the lowest y value this thing ever reaches. So 0 is the absolute minimum. Okay, x squared on the interval 2 to 4. Well, now we just want to look from 2 to 4. So 2 would be right here. X squared at 2 is 4, and x squared at 4 is way up here, and that's 16. Okay, now these are both closed. We've got these brackets going on, so they're both closed. There we go. That's what x squared looks like. And the absolute maximum is at 4. It is 16. The absolute minimum is at 2, and the absolute minimum is 4. All right. Square root of x on the real numbers. So square root of x, the whole graph of square root of x on the real numbers. That's what that means. Square root of x. Oh man, my bad move there. There we go. Square root of x does this thing. It's just a, I hope you like my sound effects. It's just a parabola on its side, half a parabola. Okay, and even though this starts to flatten out here, it's going to keep going up and up and up and up forever. However, over here, there is a lowest point. It's 0. So there is no absolute maximum because it goes up forever, but there is an absolute minimum. It's at 0, and it occurs when x is 0. Okay, and remember, when I say the absolute minimum is 0, I'm talking about the y value. When I say it occurs at 0, I'm talking about the x value, because that point there is 0, 0. All right, last one, we're going to look at square root of x on 2 to 9. There we go. So at 2, square root of x is right here, and it's open circle, or closed circle, because it's a bracket. And the y value at 2 is root 2. Plug 2 into this function, you get root 2. So that's the y value. And it's going to go out like this, all the way to 9. And at 9, this graph is 3, and I'm so silly because that is an open circle. There you go. So, there is no absolute maximum because it should be 3, this is 9. Come on, man. It should be 3. The absolute max should be 3, but it never gets there. And the absolute minimum is root 2, and it occurs at 2.